Welcome to the Raw Coding YouTube channel. My name is Anton. Today we're going to be covering generators in Python. If you're not familiar with generators or you want to know about the yield keyword in Python, you're at the right place. This video is part of a larger web scraping series, so if you're interested in becoming a data engineer, I suggest you start from the beginning. Otherwise, this video as an explanation for generators can stand on its own. Please remember, if you're enjoying the video, don't forget to leave a like and subscribe. And if you have any questions, make sure to leave them in the comment section. With that, let's go ahead and get started. And we're starting off with a list and function. All we're doing here is passing a number and then an internal number is incrementing. And for each incrementation, we add it to a results list. And finally, we return the final result. Here, I'm going to try to print out an array, which is going to generate numbers from 0 up to 5. Let's go ahead and run this application and pause the video here if you need a bit of a longer look and dissect what code is written here. But here's the result, nothing too surprising. The problem that could arise when you're writing code like this is, what if you're not generating 5 numbers, but you're generating 1,000 objects? That collection is going to take up a lot of memory. Instead of building a big list of elements, what you actually want to do is create an element, pass it along, create the next element, pass it along. So while elements are processing, you're generating further values, hence the generator concept. Before we get to the yield keyword, I actually like to build out the generator myself in order to understand it. So let's go ahead and do this. We'll create a class. This will be a generator. We'll give it a constructor. And what a generator tends to have is a current value. So let's say self current. Here we're starting with a value of 0. So let's say when we create this number generator, we're going to have a 0. A generator then has a next function, which will generally return a boolean. The boolean here represents a status if we've managed to move to the next value. In this case, the generation process looks like this, except instead of the I, we have a self current. So let's replace that with this and make sure we have the self in the function here. We then have this condition, if, and again, self current less than some kind of limit. This is where the limit is defined outside of the generator, which we pass into the generator, and we assign it as another property. We take the limit, we put it over here. If the current is less than the limit, we successfully increment and we return true. Otherwise, we return false. We format the code, we take the generator, let's go ahead and create it over here. So gen, pass 5 into it, and then we start iterating over it. So gen, while gen is next, so while we're able to generate next values, let's go ahead and print them out. And remember, we're not just getting a collection back, we're getting value by value. And the way that we process value by value is by looking at the current. You can see on line 27, we're calling the next function straight away. And generally, when you create a generator, it hasn't generated any of the values just yet. So we will assign none to current from the beginning. And then if self current equals none, this is sort of the initialization stage where we take this current, we assign a 0 to it, and we return true. If we open up the terminal or rerun the application, we essentially get more or less the same result, except the 5 is inclusive. So we can amend the original function to do something along the lines of this. Instead of creating a bulk result, we are creating more fine-grained results. Creating these classes over and over will become boring, and generators are a very, very good abstraction. So Python has generators built in. If we want to replicate a function like this or a function like this, let's copy list n. We're going to place it down here. I will scroll down and we're going to say gen n. Instead of having results and appending stuff to the results, what we're actually going to do is just say yield I. Same as we create the generator over here, when we call this function, and what I'm going to do is print gen n 5, open up the terminal, run the application, you can see here that we just have an object reference. And exactly the same thing is going to happen if I try to just print gen. because, well, gen is an object, right? We have created that class and it's an object. This generator object is basically a Python built-in object. What you need to understand here is that the yield keyword is going to turn the result of this function from numbers to an object that looks something like this. What you can do with the results from here is say for some kind of result in whatever is going to be generated. So let's grab this generation, put it over here. We will print it, each R. Let's remove these two prints, open up the terminal, rerun the application, and you can see we have two identical prints. In both cases, what we're doing is creating two generators and just extracting all of the results from it by looping over them. What if you actually want to create a generator, so myGen, and then just extract the first result, so myGen, and let's say 0. We will print this, open up the terminal, run the application, and you will get an error that looks something like this because a generator is not an array. It's not this thing in memory with all of the values already in there. You need to call the next function. And what you get with a generator is not a next function that looks like this, but rather a next function that is just built into Python, into which you pass the generator. Out here comes the value, and then you can take this value, put it over here, run the application, and you're gonna get this 0. If I comment this for loop out, and I will add another print just so it's a little bit easier to see the separation between these two. Sure, I'll have a 0 over there. I'll take the next, put it in this print, remove the v, and we'll do 1, 2, 3, 4, 5. If I run the application here, we'll see 0, 1, 2, 3, 4, and then let's do one final one, and then one more. We'll run this. We're calling the next function one more time than it needs to be, causing a stop iteration exception. This is essentially, if you're using generators, you need to listen for this exception for when the generator stops generating values. This is how it signals that. And that is pretty much generators in a nutshell in Python. When you're using the yield keyword, instead of getting your normal expected result, you get a generator object that may look something like this. You can then start generating next values by calling the next function and supplying the generator as the parameter, and the result will be the generated value. The next function is available in the global Python namespace, and if at any point you actually want to terminate your generator, and what is actually happening over here but you don't see it, is at the end you get a none. If at any point you return none, that means the generator ends. So if we rerun this, the same exception is going to be thrown here. If you have nested generators, let's say I will take this function, defGenN, I'll put it over here, and I will say genN underscore nested. Inside of it, we are going to be calling the genN function, just like that. And we're just going to do something along the lines of for I in genN, we will yield each individual I, and then do the exact same separator. I will actually replace the 0 over here. Take the for loop, put it over here, unindented, take genN nested, take the n, make sure I supply it back to the genN over here, and print each individual number, which is going to be generated. So I over here. Cool. Let's open up the terminal, rerun the application, and actually the application crashes over here. So let me comment out one print, rerun, and we get the same result. So you can nest generators. This generator is going to be consuming this generator to yield out results from it. However, there is a shorter hand for this notation. If you want a generator to pass on messages from a nested generator, you can use the yield from keyword and then take genN and just put it on the right hand side of this, and you don't need a for loop. This is going to produce the exact same result. Now that we are generation masters, let's go back to the previous concurrency asynchrony example that we had over here. And let's have a little reminder of what we have over here and what we're trying to fix. We have the thread pool executor to which we're submitting work through the submit work function. Now, what is happening, and you can see this if I highlight submit work, it is seen in a couple of places, including in our collection methods like doCollection, which is going to submit work for next collections. The problem with this is if we have many collection functions, the submit work function will spread along with them. You want to contain this sort of spread. Do collection should be performing collections irregardless of whatever mechanism you have for scheduling, executing these requests. This is how we will take submit work over here, and instead of putting the next work, we will yield the next work. So whatever mechanism on the outside sits can actually execute the do collection function, see that it's a generator, and iterate over all the results. Over here, we also have the start for our collection. So I will create a def start collection. I'll place this function over here, let me indent it, and instead of submitting work, I will do the exact same thing, but just yield do collection. Also here, I'll place print and I will say hello. And before we start, it will be very useful if I just comment all of this out. I will call start collection over here. By calling this function, I create the generator, but I'm not getting the first value. I'll open up the terminal, run the application. So Python 3 test. And you will see that hello is not printed. The reason it's not being printed is we never enter the function body unless we start generating values. So that is actually very important to know if we are going to be executing generators in parallel. What is currently happening, and let me take all of these collection requests, move them above the thread pool executor, and make sure that we're looking at the scheduling and draining of our workload over here. We have the submit work function, and everything is going to start with submitting work of start collection. Start collection as a function produces a generator. If we submit this to the executor is just going to be creating generators in parallel. What we want to do is make sure that the executor internally is actually going to be generating in parallel. So let's create a local function and give it maybe a little bit of a better name like unpack, and it's going to be accepting an FNC, which is really just a wrapper for fn. So instead of capturing the variable locally, the fn is going to be passed into unpack right over here as a parameter, okay? So FNC at this point is really fn. Inside unpack, so in parallel, we're going to be executing FNCs and we're going to be getting some kind of result back. If this result is going to be a generator, and the way that we check this is instance result and compare it to generator type, we will import this. So from types import generator type. Then we want to iterate over each individual thing that that generator is going to generate. So for n in result. And what do we do with this n? If start collection is going to generate do collections, these are going to be further generators. If we try to yield them from here, unpack in turn will become a generator. And again, we will just end up reproducing a generator in parallel. What we want to do is take this n function, which is going to be do collection, and pass it along to submit work. So we just resubmit the next work by the time inside fn do collection comes around. So we get do collection, FNC will be do collection, we execute it, we get a result, it's going to be another generator, each individual n is going to be the next function. Then the next function comes around in the fn, it goes into FNC, we execute it, and because we don't return anything here, it's going to be none. So otherwise, if it's anything else really, let's just go ahead and return result. I'll remove the 32 over here, I'll take submit work, I will move it into start over here. Let's open up the terminal, rerun this application, we will see hello, and we will see that we're collecting 25 items in 0.44 seconds. If I drop down the terminal, we will take a look at the start collection over here. We still see we have a results queue, and ideally what you want to do is introduce another yield over here. So whatever functions you have, they can produce next work or they can produce collected items. Your web scraper is this thing that is constantly crawling and crawling the internet and is emitting more and more items. If you have a massive collection where your spider is crawling thousands and thousands of pages, you don't want to have an array which is slowly being built up. You want to yield out these items and maybe send them off to a different API, which is going to store them in a database or save them to a file or something like that, away from the memory of your Python application. But let's return the yield over here. We will keep this compilable. We're gonna close test.py, gens.py. We're gonna go into scraping, BBC food, and run. And we're gonna make sure that in collect recipes, where we were passing the runner, we actually want to remove the runner from here, okay? So remove this as well. So self runner no longer exists. Let's make sure that we remove it from here, here, and then submit result as well here. Instead of submit result, we're going to yield. We're going to yield here as well. I'll remove the parentheses. When you're yielding, you want to make sure that you're not yielding with parentheses. When you put values inside parentheses like this, it means something else, okay? We'll remove this parentheses on the end here, and we have quite the pickle. So first of all, recipe will be a dictionary, and we're going to work off the assumption that every item that we collect is a dictionary, and that is just gonna go and be saved in the file. The next request over here requires a URL. So we kinda need to pass this along to the submit executor, although we essentially want to package it up. Let's go into scraping over here. We will create a new file and we'll call it task.py. And here we'll create a class, task, and this class is going to be really simple. All we're trying to package up is parameters to a function, so args, wargs, I don't know about that name, but usually this is called quargs, so I'm just gonna do the same. We are going to preserve all of this, so the first parameter is going to be the function, so self fnc equals fnc. We will then duplicate this a couple of times. We will take the arguments, make sure that we're preserving them. We'll take the quargs as well and make sure that we preserve them as well. We can take the task. Let's close this. When we deal out the next thing, what we really want to deal out is a task. Let's go ahead and import task, our task, not from async.io. Let's spread this out a little bit. The function that we want to perform is going to be the self next request, and then the other argument is going to be URL. Make sure to assign it over here, and this way we have essentially rid our collect recipes from the runner. Now we'll close collect recipes. We are gonna go into the run function where we have the runner and we have the run scrapers parallel. The initial work that we submit over here, we have the entry point, the args, and the runner. Let's get rid of the runner. I also believe in the main py over here, we have been accepting the runner. So let's remove this and we no longer have the runner here. Default function actually becomes this, where we yield, let's actually leave the collector over here, a task. So this is again our task, so scraping.tasks. For the FNC that we're gonna have, we're going to grab collector dot submit work, remove the dot over here, and actually submit work function was on the runner, so we want a collector start collection and then search term as the next argument. So let's just pass it along here. Let's remove this, and there we have it. If we close main py, we see submit work and get results. Let's go into submit work and apply the same logic that we have done in the test. We will scroll down, we will go to the unpack function over here. We're gonna copy it, come back to run py, and when we submit work, so right over here, let's indent this, take unpack, pass it along instead of fn, pass fn as the next thing, along with the other args and quargs that could be there, and again pass them along to the original function. We'll get the generator type, make sure that we import it. And for us in collect recipes, it's really generators all the way down because we're actually implementing it with the yield of these dictionaries. So we don't need this else keyword, and potentially we don't need this if statement. However, maybe something along the lines of this, and do something like a raise exception or something like that. So I'm actually going to remove this if statement. Just understand that this will yield the generator as long as you're putting yield keywords. Otherwise, you need to check. So actually, let's just make sure we have the if statement over here. And otherwise, I will erase exception. We'll say didn't return generator. For each result that we generate, this could be a task. So if is instance, and again we have n, this could be a task. Which task? Our scraping task. If this is indeed this kind of task, we want to go to the self submit work, and from this task grab the func with the args and the quargs and make sure that we spread them. So add the star and add the 2 stars over here. Otherwise, else if, or rather this is elif, is instance, and n will be dict. We want to go to self, submit result, and just pass the n along. Because external dependencies actually don't need to call the submit result function, we can use this functionality directly and put n in here like this. Let's remove a couple of white spaces. The rest should function just as is. Let's bring up the terminal, scrape, BBC food, and pizza. I've cut the video at the error here. Basically, I tried a couple of things and then I just again realized that I'm not supplying the parallel flag. So let's go ahead and do that. And we'll see that we're actually hitting an error that we're not returning a generator. So what are we actually returning at this point? So let's print out the result, rerun. When we are not getting the generator, let's extend this. Printing this, I can see it's a generator type. And I can see that there is a not here. I'm not exactly sure where that not came from. I don't know if I copied it from test spy. Definitely didn't come from here. Yeah, not sure where that came from. Let's rerun. BBC food main pie task takes no arguments. Let's just double check that we have the correct task. Let's jump into task, and again, another fail from me. Sorry, this is meant to be the init function or the construction of the class. Let's rerun. The next error we're getting, the JSON object must be string bytes or byte array, not none type. So we're getting a none type somewhere here. When we run scrapers in parallel, we're gonna get results over here. Let's just print them. So results, return results, and in between print results. Open up the terminal, rerun, go over here, scroll up a little bit, and I actually don't see anything. I'm hoping this is not actually a problem with the website. So collect recipes on line 25. Let's give a print here, JSON string. Let's run this. We actually see none. So let's grab this and go to the website. Here we are again, searching for pizza, going into the network, and let's actually turn everything off. So pizza. Let's grab JS search data, come back over here, all the way back to the top, the document. Let's spread this out a little bit. Response, Control F in here. And JS search data is not actually here anymore. In here, let's search for pizza dash sauce. There we go. We have a couple of more of these findings. Let's keep scrolling until we find something like this. I'll go all the way back, and here we have something that looks like next data inside of script. Let's take next data over here, come back, and we'll change attribute ID to next data, grab all the text, and then try to parse it. So rerun. I'll go up here, and it looks like we're basically getting most of the data, although it seems to be in the wrong format. Rest in peace, all the viewers who are going to be following the food scraping from like a couple of episodes ago. Let's try to prettify this. Take this JSON blob. Let's put it in a JSON file. So I will take the output, paste it in here, and try to format it. I'll drop down the terminal for now. We're going to go all the way up. We have page props. We have a bunch of tabs. Total, blah, 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 blah. Nobody cares about this. Let's search for pizza sauce. There it is. This is going to be in search results items. And let's just double check that the search results are going to be on a good level. So let's just grab all of this filter stuff, remove this, tabs, remove. So inside the objects, page props, search results, let's come back to collect recipes. where we have the JSON string and we load it. We want to go to props, close this off, and then in output JSON, page props, let's keep going. Back to output, grab search results, put them over here. Back here, we have items. We'll grab items, put them over here. Back to output JSON. And this looks to be more or less the same, except all of the terms are different. Okay, we're going to change this to just have the title and the URL. I'm not going to mess about with the rest. So here we have the title, then the URL is the next, and that is still there. And the description, we can also grab the description. So let's go ahead and keep that. The diet I'm going to comment out because that is now broken. The print has been removed. Okay, let's go ahead and rerun this. Let me pop this down. I must have left a print on the result here. Yep, let's remove this and let's make sure that we just return. Check the output. This should be overridden with all of the recipes that we wanted to scrape, right? And there it is essentially. Okay, so just to quickly summarize again, we had our collect recipes depend on the runner, and we had to submit things into the runner as we were collecting it. So what to execute next, what have we collected, all of that malarkey. The thing that is doing the collection doesn't need to worry about what the runner is, where it exists, etc. We just want to say we collected a recipe and this is what you should do next. So on the outside, in the runner, that is what's going to take care of receiving a generator, making sure it creates the generator, executing the generator and all of the following values, and again, resubmitting them back to the executor, making sure that all of the tasks we asked it to create get executed asynchronously. And this will be it for this video. A little bit of a bumpy ride at the end, but that is just the nature of the beast. In web scraping, you depend on external parties. They're gonna apply their changes whenever. Potentially what could happen, I will release this video and they will actually roll their changes back to how they used to be before this video. So this could actually be a very important lesson where you're trying to scrape BBC food and you try it one way. If that fails, you fall back to the previous way and perhaps that is still going to work. Nevertheless, hopefully you enjoyed this video and learned something new about generators in Python and how to apply them to your work. Thank you very much for watching. Don't forget, if you enjoyed the video, like and subscribe. And if you have any questions, make sure to leave them in the comment section. And if you really enjoy my work and want to say thank you, please come support me on my Patreon. Very, very big thank you to all of my patrons that are already supporting me. Your help is very much appreciated. Again, thank you for watching and I'll see you in the next video.